Welcome to the Energy Storage Q&A series. This is a special episode as we have invited a few of ATX experts to a roundtable discussion on how operators can increase their network's reliability and customer satisfaction with innovation in energy storage. I'm Julie Davis, the VP of Sales for our Energy Division here at ATX Network. Gentlemen, can you each introduce yourselves, starting with George?
Hello, everyone. My name is George Goncalves. I am the Director of Product Management for the Energy Division of ATX, located in the Atlanta area of Georgia.
Perfect, thank you. And Doug?
Hi, I'm Doug Ridley, Vice President of Engineering, and I lead the engineering at ATX for our energy storage products.
Great, thank you. George, we are going to start with you. So we've already learned a little about sustainability and reliability in a previous episode of this series, but let's dive into a bit more with our experts here today. Can you explain how the Eureka hybrid supercapacitors help operators meet sustainability standards for their networks?
Sure. So sustainability for a lot of customers can mean a lot of different things, but in general, it's a way of life for these customers. They have a means of being greener for the environment, and the Eureka hybrid supercapacitor is a means to get there. It's an enabler. Whereas some products that may be in their network, older batteries that can be recycled, they die off quickly, and yes, they can be recycled, but the process has to happen multiple times. In the Eureka hybrid supercapacitor world, it's 100% recyclable, but because it lasts 20 plus years, you don't need to recycle it anytime soon. So that event of recycling gets pushed out quite a bit, so it's a much more sustainable product down the road.
Great. And then Doug, for network operators evaluating backup power solutions, what role do hybrid supercapacitors play during outages? What factors should dive into the decision to deploy them alongside instead of the batteries they have today?
Excellent question. Hybrid supercapacitors are an excellent storage device that provide reliability, but most of all, predictability during outages. Not only is it a great way to back up their network, but it's also great to use for timing when the batteries might run empty, so you can deploy assets to bring those sites back online. Operators leveraging hybrid supercapacitors have the distinct advantage over the VRLA product simply because it's safer, it's more reliable, it's more predictable, and it's a solution that they can use to maintain quality of service in comparison to other energy storage mechanisms.
Great. This one will be for both of you. We'll start with George. What are the key safety and maintenance advantages for hybrid supercapacitors, and how do those benefits translate into lower cost of operating costs for the network operators?
So in the hybrid supercapacitor world, maintenance gets to a point where it's almost negligible. The VRLAs or lead acid or other types of energy products have to be maintained on a regular basis for their health and safety, so that they don't off gas or they don't have any type of leaks. And so the maintenance becomes a cost adder for the product. Whereas in a hybrid supercapacitor world, you don't have to maintain it. It has a set and forget type of mentality. So when you put a hybrid supercapacitor into your network, it just works. It doesn't need to be checked. It doesn't need to be maintained. And those truck rolls go away, and that's cost savings to the end user from an operational standpoint. So it saves some money over time.
Doug, anything to add on that?
To expand on what George said, beyond just the relative simplicity to install and things that it does to provide more resiliency in the network, safety and the maintenance advantages translate into permitting and deployment. So the testing that we've done to date, work we've done with regulatory committees, really reduce the amount of truck rolls required, along with compliance necessary inside assets that have batteries deployed in general. Hybrid supercapacitors, because of their chemistry and testing, allow operators to deploy in places that make other energy storage devices almost impossible to actually deploy.
Great. Anything also with our carve out with the NFPA 855, anything to add with that?
One of the key differentiators when we speak about hybrid supercapacitors is it's no longer lumped into the standard lithium-ion battery regulatory stuff within inside the NFPA. Hybrid supercapacitors have been carved out intentionally because of safety demonstrated through third-party test and UL testing. Due to that, the ability to install in brownfield environments require no additional cost when moving from a VRLA to a hybrid supercapacitor. Those kinds of advantages do not exist with other lithium-ion based technologies.
Thank you for that. Now, I know obviously we were just talking about with saving money. One of my favorite feature sets of the hybrid supercapacitors are obviously being able to utilize it for peak shaving. Now, can either George or Doug, can you explain with the Eureka hybrid supercapacitor saving money, but also with energy arbitrage as well as maybe a revenue stream for customers?
I'll take the peak shaving side of the equation. In a lot of energy sectors, and the cost of energy to an end customer varies over time, and it varies different parts of the day. And in the afternoons, where there's a lot of usage of end users, the utility companies will raise the prices to deter you from using that energy. So when you're using your product in the afternoons, the cost goes up. And one of the features that works really well with our product is the ability to turn the energy away from the grid and onto a hybrid supercapacitor during those times of high dollar events, and then recharging that said battery during the hours where it's much cheaper. And in the long run, the company is not spending the dollars when it's on the grid when it's expensive, but you're actually using energy that's stored in the hybrid supercapacitor that was bought when it was much cheaper. So the operational expenses over time go down because you are peak shaving, you're going off of those peak times and using the energy more effectively.
Perfect. And then Doug, if you could cover the energy arbitrage portion.
Energy arbitrage is a generic term for time of use is included. But expanding on that, assets deployed with hybrid supercapacitors can now be deployed safely back into the grid, meaning that there are additional rates available to operators where if customer has enough hybrid supercapacitors and they can spare the extra energy, they're able to actually deploy that energy back into the grid, supporting homes and cars getting charged and things of that nature. In those events, they can turn it into a much greater revenue stream where the stored energy bought during the low period can now be deployed during the high period.
I wanted to add something on there. So with our depth of discharge, being up to 100%, and you have VRLAs that are about 20, 30%, and then lithium ion about 80%. If someone was trying to say, oh, how do we compare it if we're going to utilize it for lithium ion or VRLAs? Like, what are some key differences between scaling these units? Do they need to have, sometimes with the VRLAs, they're going to have to add much more to get the same depth of discharge that ours? Can you explain that a little bit more too?
Okay. So when it comes to depth of discharge, the VRLAs and the lithium ion have a limited scope of how it could be used. So in the VRLA world, the customer selling the VRLA will say, yes, I have this much capacity, but I'm only wanting you to use maybe 30% of that. So really 30% is actually usable before it starts to erode the life of the battery. So you have to buy much more battery for the actual usage over time. And lithium ion is the same way. You use about 80% of what you buy from the vendor from day one. In the hybrid supercapacitor world, because we have 100% depth of discharge, you buy and use you use what you buy, and so there is no variable of, hey, over time do I have to buy more energy because of the degradation? It's not the case. In the hybrid supercapacitor world, you buy what you need and you get that capacity throughout its life.
Well, thank you, Doug and George, for joining, and thank you everyone for watching. If you have additional questions about increasing your network reliability with Eureka hybrid supercapacitors, you can either send us a message on social media, you could go to our website and reach out directly there. You can also watch past episodes of this series at atx.com/energy series. Thank you so much for watching. Have a great day.
That's a wrap on the Roundtable segment of the Energy Storage Q&A series. You can download the Peak Shaving and Energy Arbitrage ebook or watch a previous segment at atx.com/energy series.